So for those who are remote and everybody in the room, we are resuming with the IMG session, and we have 3 presentations in line from Patrick Lecalais. So Patrick, floor is yours.
Okay. So
Take a mic.
Yeah.
What do you want to do?
First of all, I'll share the stuff. Voilà. Okay. Effort number 1. So I think some people want to get in the room. Yeah, so it's IMG session. So I want to tackle with this first presentation something a bit different, or we didn't touch too much in IMG, but I may be wrong. It's interaction between vibroacoustic discomfort and visual stimuli. So now we are entering in kind of a multi-modality and to compare a real 3D and 360 environment. I will define what is 3D and 360 environment in that case. So this work has been also presented at IEEE VR. That was we have the bench of presentations that were presented at this VQEG that are coming from IEEE VR. So a quick introduction. So it's a different usage of VR. It's not the social VR like the test plan that has been done for the IMG VQEG group. It's more for building studies. So why it's interesting to do building studies? Because before you may design a building, you may think about a different way to design it for different purpose, for different use case, and VR offers the possibility to prototype the building before to do it, and eventually to prototype it in a ecological way, in a sense that you can test the true usage of this building. So especially for this work, we are interested in design of workspaces. And some workspaces, you may have many things that may affect your productivity, such as thermal ambience, acoustic ambience, vibration, all these type of things. So this is why we are interested to study that. So the impact of visual, acoustic, thermal, olfactory signals on well-being, comfort, health, but also productivity in that case. Of course, you may wonder if there is a relevance of immersive technology for this. So in this study, we try to understand the validity of VR. The idea is we had some experiments that we did in the real world, and we reproduce this condition in so-called 360. I will explain, or 3D environment, and we're gonna study several things like which VR format provides the most ecological validity condition to study human perception for building studies. How the discomfort to sensory stimuli perceived in VR versus real environment. So how do you so I will show you a few things here. So we're gonna do a few things here. So sensory information. So we're gonna do visual plus vibroacoustic stimuli. And make comparison between different situations, and we're gonna evaluate not only how you feel about the environment, but also some kind of discomfort evaluation when performing also cognitive tasks. So to do this experiment, we started from an experiment that has been done by CSTB. CSTB is a public organization in France, which is the kind of national center of scientific research on building and environment. So they have this setup where people are seated on at an office. They can do a task, and They simulate acoustic with an acoustic system. You can simulate noise, and they have also very interesting here a system on the floor that is a vibration system that simulates, for instance, passage of a metro, tram, or train, or stuff like that. So it's really shake like what you could experience in a building. So they did preliminary experiment, and out of this, we select from this real world scenario the most interesting stimuli condition where we could see that there was a true effect on cognitive task. So then we reproduce actually this environment to run experiment in VR in two ways. One was just to take the picture of the 360 picture of the environment. You are still in VR, and it's just a projection, like as if so you have the office, you can vote and everything, but everything which is the environment is just projected on the sphere. And we have a second environment where we reproduce everything in 3D. So this is really 3D object, 3D assets that we use with Unity to reproduce the same environment. Okay, so then because we are dealing with productivity, we had a cognitive test here. So the cognitive task was to you have some it's a word memory test. So you have 50 seconds to memorize 12 words and 15 seconds to find the words among 30 distractors. So it's so you have to do something, and we're gonna check as your performance is affected by the noise or the vibroacoustic conditions. So the study design protocol. So first, you are hosted in an adjacent room. Then you come into the lab. We install physiological sensor because we're going to measure also EDA, electrodermal activity, galvanic skin response, and different things. So there are several steps that I'm going to describe here in this protocol. So first, the physiological measurement, heart rate, EDA, cutaneous microcirculation, respiratory rate. But for the work I'm going to present today, I will focus only on electrodermal activity. So we have questionnaire. So there is a first step. You are into the environment, and we ask question after exploration of this visual environment, your emotional state. So we pick 3 questions among those who are existing in many questionnaire, and also the visual perception. So how do you feel about your visual perception of the environment? Then we have the subjective questionnaire related to vibroacoustic stimuli. And there are 2 types of questions. One is which is more about how you notice the noise or the vibration or both. And the other one is on a scale to 0 to 10, how annoying was the noise? Okay, so did you pay attention to it, and how annoying it was? So it was 2 different questions. So just to clarify, so first you have the exploration of the environment. We have the emotional state questionnaire, visual perception questionnaire, and then you enter into that second part of the experiment, where you have 1 stimuli, sound sequence, vibration, and you have to reply to the question on perception and discomfort. And then, similarly, we repeat this, but this time adding the cognitive task, which is how you remember the words and everything. So we had 3 groups of subjects. Some did the experiment only in real, some did in 360, and some did in 3D. And this is some analysis of the subjective response. So here it's more about how you feel about the environment. So this is the result of the first phase. And I don't know. We were discussing that yesterday, I think, with Kamel. That was the problem with 3D here. If we look the things from ecological viewpoint, it tends to elicit more positive emotional state, a little bit like a wow effect, despite less visual comfort appreciation. So people feel less comfortable, but they are more excited and they feel excited about it. So this could be a limitation also on how you can do valid experimentation between real world and VR. So, but you can see from the different question, this effect exists, but it's not that important. So now we can be interested by how people feel about the discomfort of vibroacoustic signals, so the third part of the experiment. And we look the things from discriminability of vibroacoustic signals. So remember, we don't have that much conditions, and we tend to look how people are able to discriminate the different conditions. Here you can see that in the case of cognitive task, you tend to perceive less the noise or the annoyance of the noise. You can perceive it, but you between the conditions that we tested, the different stimuli, you cannot really tell the difference. So in other words, the cognitive load makes you, let's say, less discriminative in terms of intensity of the stimuli. The thing which is interesting is that you observe this in all the conditions, real, 360, and 3D. So basically, in terms of discriminability between the stimuli, the number of discriminable stimuli are roughly the same between all the conditions for sound, for vibration, for composition of both, irrespective to the environment. And if we add the cognitive load, things are in the same. Another thing which can be interested is to, because it's a memory test, so you can also measure the performance on the memory if people manage the things correctly, and how it is correlated with discomfort. So here it's negative correlation, but it's normal. It's a discomfort versus performance. So the more you feel discomfort, we are expecting that the less you are performant. And you can see that it seems that 3D and 360 conditions elicit more this effect of correlation between discomfort and your performance in memorization. So real environment, slight trend observed, but not significant, while for the other one, you see for 3D and 360, we see more. So that's a bit annoying, I would say. If we look at the physiological signals, so in that case, the electrodermal response, so we observe, we look at two information in that signal, the mean peak frequency comparison and the mean peak amplitude. So in terms of mean frequency, you see it's kind of similar, not really significant. They are a bit different in simulated environment. Usually we observe more peaks and lower amplitude in simulated environment. So it seems that for this particular electrophysiological signals, real conditions differ from 3D and 360. Okay, so this was just a preliminary experiment and probably another use case of IMG for IMG. So can we use VR and but still we are relying on questionnaire. So this other type of questionnaire, other type of task is not social interaction, and also we could look a bit on electrophysiological signals. So yeah, the main takeaway currently we are working also on more unpleasant environments. So we play with conditions that may affect your mood, similar to the valence arousal stuff that we've seen this morning. So we play a bit with this, and and that's pretty much it for this first part. I don't know if you have any question.
Questions for Patrick?
Could you go back to the bar charts where you shown the different axes for the three different environments?
Which one?
The three color bars, different color bars.
This one.
Yes. It's not obvious to me that 3D elicit. Would you like to elaborate? I see a few of these axes where it does elicit, but others where it's actually decreasing, right? For example, lightning appreciation. I would argue that 3D less positive, right?
Yeah.
So I'm trying to understand, did you weigh these differently? Why did you come to this conclusion? I see less positive than negative personally. Unless I'm missing something, because I missed the part, maybe 5 minutes of your presentation.
The lighting appreciation is not necessarily the emotional state, right? It's something that you appreciate if it's so I would say emotional state is more the two.
The arousal and
yeah.
But again, I see arousal and emotion.
Yeah, but the emotional balance is you see.
Okay.
This is why you see something which is more positive.
I see. So it's maybe then again, apologies, I missed. Maybe you should just circle the first column because it doesn't really come up the mess. Okay, thank you.
Short question, Patrick. Why did you choose this scale 0 to 8, not 1 to 5? Was the justification for this scale? Is it a strong justification?
No, because it's coming from building studies actually. So some comfort. That's a good question, but that's something we observe in other studies, especially in the field of building studies. So
great. Thank you.
Of course, here in this group we may have another, let's say, vision on that, especially when it comes to SER. Do we need 3 category, 5 category, 10, 11 points? I don't know how many discussions we had on that. So to at least, because to promote this in the building studies community, we did not enter into that discussion.
Mm-hmm. Or maybe this discussion was closed years ago.
I was going to ask the same thing. More questions? No more questions, so we continue with the next one.
Alors, which one is the next one?
You can choose.
Allez, for Baloo, I think this one you're gonna love. Maureen is okay. So it's more about the perceptual quality assessment of Vision Pro based egocentric spatial images. So that's another thing. So the things that we did also with the friend of Shanghai Jiaotong. So background and motivation. So here is what we need to study egocentric spatial image quality assessment. So yes, it's a limitation of traditional 2D, 3D image quality assessment for this type of content, egocentric content. So by egocentric content, we mean things that you can capture from your from a camera, variables. So it could be the Meta Ray-Ban, could be also the Vision Pro, and especially here with Vision Pro, it's also stereoscopic. So it's kind of interesting, and we want to gap and see if existing metrics how they can take care of stereoscopic depth, but also immersive field of view and first-person perspective. So it's a mix of egocentric, and I will come back on another concept after, embodiment also. So the data set is composed of 500 images. So this is image, not video. Some were captured with Apple Vision Pro, some were captured with regular iPhone, but using two sensors to generate and synthesize a 3D view or stereoscopic condition from the sensor. So there are 22 participants and 3 display mode. So a few words about the display mode. We have the regular 2D condition. In that case, only the left view is tested. Then we have a kind of 3D window. So you have to imagine it's just, you know, a floating window in a Vision Pro, and you have like a screen projected in your environment. And then this is what I call egocentric and embodiment vision. That means egocentric in the sense that the image has been taken from egocentric viewpoint, and you watch it as if you were the one that has taken this image. So this is more an embodiment of the egocentric situation. So especially for video, it can be a bit confusing, and for image, we wanted to study that also. So you have a bit of some observation, but they are much more in the paper if you want to look at some aspect of the data set. What do we learn? What are the difference between the condition and so on? So you have some kind of a most trend for all images, for those who are captured with Vision Pro and those who are captured with a regular phone. Depending, it's watch on 2D, 3D immersive, 3D window. You will see some kind of trends. The most score are changing. So as the viewing condition may affect your feeling of quality. So we tried actually, because that was once we have this data set, to see also if we can capture the different immersive viewing conditions with a metric, and especially to fill the gap of field of view, depth, and also the fact if you look in 2D, if you look in the window or in 2D. So for this, we came up with a new model, SEQANet, that capture both pixel details and immersive perceptual effects that define egocentric content quality. The thing which is interesting here is it can learn the things across different display mode. So it's dynamically adapting to display mode during unified training. So you have a kind of unified training that helps you to understand what you get if you are in 2D, in 3D, or the embodied situation. I'm not going into details, but okay, there is a transformer. It's based on Mamba 2. You have multi-stage fusion model. It uses cross attention. Transformer, you know, its attention is all you need. You have cross attention module for the binocular. I don't know why this stuff is moving along. Yeah, cross attention for binocular fusion, transpose attention for channel interaction. So it's a bunch of different things. When it comes to result, compared, I'm not describe all this table, but the thing that was interesting is that if you look, the capability of this model was actually to across all the condition, 2D, 3D window, and 3D immersive. So this model is able to have a kind of a well-stabilized prediction as opposed to other model. So we have a bit of a improvement here. So that's okay. This is something. This is a present for Lucas because we did the Krasula analysis in this study, and where you can see that this metrics is definitely much better for the better worse analysis. This is a proposed metric. It outperforms all the rest. So it's pretty interesting because you can help you to benchmark a few things. Et voilà, number 2. So you have access to the database, you have access to the code, and of course you can contact people.
Thank you. Can you go back to the table?
Oui.
Were the other metrics also retrained?
Some, yes, when it's possible.
Which ones?
No, I think there are some methods which are not trainable. Okay, so it's from the nutshell, and I don't want to say any mistake. We can look in the paper on this.
What makes apart from the mechanics of actually using the Vision Pro, is that really limited just to Vision Pro, or these are generic results?
What do you mean?
because in the presentation you specifically call out Vision Pro. Is that something in this work that is specific only to Vision Pro?
But the fact is that for this part of the experiment, okay, we were using Vision Pro, and that's a good question. Is that probably we could reproduce part of it, but the thing is that here we were in the Vision Pro ecosystem, right? It's image capture with the Vision Pro and watch in the Vision Pro. So that's end-to-end Vision Pro. Let's say from capture to
Yeah, obviously the interest would be to cross-check, right? Capturing with Vision. And there is one component by using just the iPhone, you can say it's a different path. And you are also viewing it in a 2D.
Yeah.
But I would, so, I mean, in my opinion, it would be good in a evolution of this to include more capture and more rendering devices.
But yes, you're right. But the idea also here is to say, okay, we're gonna have a multiple device, variety of device to capture our to capture UGC these days. So it can be Meta Ray-Ban, can be our phone, can be Vision Pro like stuff. So UGC content are coming from various sources, and they can be consumed in various ways also. So can we have a kind of a unified metric or way to measure all these things? That was the idea also. And this is a preliminary work, but offering to discuss this thing, right?
Thank you.
More questions?
What do the defects come from? I mean, for evaluating different qualities, or it's just
there is no
opinion.
Compression artifact, stuff like that. So there it's it's mostly a capture artifact or bad or synthetic. The fact when you do you go from two image to from the iPhone to synthesize stereoscopic conditions. So yeah, there is no capturing rendering. Yeah.
And how big were the differences between the different evaluation types for the same images? So how did you compare the results from the 2D setup with the 3D in terms of the correlation of the ratings of the people? Or maybe you showed that
So I have to remember because there are some other analyses in the paper. Here you can see the distribution if there is a shift actually, but that's not per image, and that's I guess what you want to see. I can't remember we did this. The correlation between the viewing conditions. I can't remember that.
Bottom line is, to far extent, you can evaluate these images in 2D without needing an HMD, right? So that's
but image is one thing. The next step is really, and we started to do that, the video, because the video, then it's especially the embodiment of egocentric conditions. This is where the things can start to be a bit
I know
discomfortable, extremely
I know.
discomfortable.
This is why, as much as you can do in 2D, you left less things to do 3D, so you can somehow balance. So that's the question. Do you have the scores in the dataset too?
Yeah.
Okay.
Yeah.
And the dataset is public, right? So
yeah.
So if you could show the last, and I can take a picture. Thank you.
Yeah.
Patrick, I have a quick question. So I'm a little bit curious why Mamba 2, because like there's not much of state space differences between 3D, 2D, and immersive. But like, I mean, that aside, maybe implementation detail, but that aside, like, is there a particular way in which you are like trying to capture the egocentric features, like head movement and stuff like that?
Which feature you mentioned? The egocentric, which one you said exactly?
Oh, when you do the subjective experiment, like how much of like head movement and other stuff are you tracking?
We didn't include that.
I see. So when you plan to extend this to video, like it probably will be beneficial to know.
Absolutely.
Yeah.
absolutely. And especially it affects a lot of your score. And possibly also we should also maybe correct the egocentric video to your to not have this disruption between your own motion when you are watching and the one who took the picture. No more questions?
More questions?
Oh, les pauvres.
No more? Last
Allez.
one?
Allez.
You're in turbo mode.
What?
You're
Allez, last but not least. I said 15 minutes for each, so it was not supposed to be that long. It just this presentation is just to open the discussion or view on other scenario for IMG, because we are about to provide this recommendation, and I think we can expand also the view. So one was also this type of device UGC in IMG, variety of capturing device, variety of viewing conditions, and I think that's kind of interesting to stress that. That was this presentation, and the very first one is are other use case in VR where we need also to study some QoE stuff, and especially considering multimodality. So the effect on of different type of stimuli, and especially in specific tasks, different tasks. Okay, so and now I want to expand that a little bit more with the last presentation. Voilà. So we're going to talk about QoL. So quality assessment with extended reality, and especially I will today talk about orientation mobility test in virtual reality, quantitative assessment of functional vision, data sets and evaluation. I will explain all these things now. So earlier today, we had a provocative presentation on why should we exclude people who are not necessarily, why do we screen some people and so on. And I think there is an avenue actually for studying people who are not, let's say, typical people. And I think this is not only an avenue, we need to do that. And that's why I started to embrace these things. So first of all, QoL is quality of life. So there's a kind of a quality of life definition here. Yeah, I can see Jesus smiling because why are you laughing? You know this picture, where it's coming from? Amsterdam, Social XR Spring School. So that's absolutely, and then there is UGA. So the work I'm going to present is mostly done with. I have 2 PhD students working on that, but UGA initiated most of the things I'm going to present today, and yeah. So QoL is a measure of subject well-being, and or a certain medical condition may affect a patient on an individual level. So why I think it's important, especially in our case, because there is a true societal challenge related to low vision impairment. So this is a problem. You have and more people are affected by that. So because population is aging, you may be aware about DMLA, glaucoma, these type of things that affect your visual field. So, but we have also some other type of disease which is appearing, and at the same time, you have way to fix some of them through surgery, through remediation exercise, or through medication, especially genetic treatment. The problem is that if you want to put something on the market, you need to prove that the patient, there is a benefit for the patient, irrespective of surgery, medication, or remediation protocol, you must prove that there is an improvement for the patient, and in that case, questionnaire is not sufficient. So you cannot rely on questionnaire. So you need to prove that there is a true benefit. If you look at ophthalmology device to measure, we have a lot of tests to measure the so-called visual function. And in VQEG, we know that very well because this is the things that we are using usually to screen our panelists, like visual acuity, visual field, contrast sensitivity, color vision, all these type of things. This is the way we measure different visual function. But the thing which is more important to measure if there is a benefit for a patient is the so-called functional vision. And functional vision refer to the way you use your sense of vision to perform daily life activities. So it's vision in function, if you want. Whatever it is, your different visual function are affected. It's how you use this sense to in your daily life. Usually, this is done with questionnaire. But as I said, questionnaire are way too subjective for some regulators in healthcare to let people go for that. So to validate medication. I want to report this story because I think it's to me it was really a moment where I decided to work on that. So there is this medicine so-called Luxturna. It's a genetic treatment that can fix some disease, genetic disease of the retina. So it's one. There are not many cases like that in the world. Maybe we are speaking of a cohort of a few thousand people who are affected by this disease. It's kind of orphan disease. But it turned out that one laboratory was able to develop a genetic treatment, and with one injection, you can fix the problem on the sensor on the retina. The question is that, okay, you fix the sensor, but the rest of you don't know if the visual cortex and everything is able to process this information. So, and you have to prove that there is a true benefit. So this medication, because there was nothing else than the questionnaire, was about not to be approved. And that means these few thousand persons that I was talking about will never have the chance to get this medication. So there have been to overcome with that and to measure and quantify how the functional vision was improved. A mobility test has been designed. So you can see it's the form of a maze, okay, where people have to navigate, and they do that under different luminance condition, and lighting condition, okay. So you do that before injection, then you do it after injection under several light, and we can see if you navigate better in the maze, if you do less mistake and so forth. Of course, to avoid the memory effect, each time you change the lighting conditions, you have to change the maze. So so it's pretty, I mean, intense to operate. So there are not that much maze. I took the example of Luxturna, but actually this test has been deployed for other remediation process, other medicine. But as far as I know, in France, we have only 3 mazes deployed in some hospital because it's a whole operation. You need to recalibrate the lighting, and it's you need to change the configuration. So it's not super, let's say, popular and well deployed. On top of that, you see, when you have to imagine when you are very low vision impaired, some people don't want to do the task. It's kind of risky. So either they don't dare to do it, or or either they do it, but they can take some risks, so it's a bit complicated. Anyway, just to because we like standard here. Actually, this stuff is patented, is licensed. The maze itself, and so there is a whole service associated to that. So there's a company who record the video and so they license the maze and they provide the service. From the video, they compute some kind of score to say if there is an improvement or not an improvement. Anyway, thanks to that, Luxturna was released, and a few thousand people could get benefit of this treatment. So why we are going VR here, and this is what we developed. So it's as you can see, a seated orientation and mobility test. So it's kind of similar of what I've just shown you in real life. But the thing which is interesting with VR is that, first of all, it's flexible design and reconfigurable. So you don't need to manipulate stuff. You just click and you change the maze. It's much safer. Okay, so you don't have this problem. I don't want to do the task, or you see the person is just seated. So it's cheaper. And on top of that, you have access to behavioral data almost for free, right? The other thing is that, okay, you have someone navigating and you have to do everything from computer vision. Well, if you have an HMD, you have all the behavioral data, head tracking, eventually gaze tracking, all these things. So you can collect a lot of things almost for free. You just need to log what's going on in the device, as long as the manufacturer opens this, because you know that there are some kind of privacy issues also these days. So this is why we started to develop this stuff. And the reason why I'm talking about that also today is because I noticed that IMG, for the recommendation now, you are kind of stuck at the moment where, oh, how do we make speak this data? We have behavioral data. So I could spot two problems: how to share the data and how to analyze the data, especially behavioral data. So I just want to report a few things around these things now. So let me show you how we try to refine the functional vision assessment in virtual reality. So this thing was presented also at IEEE VR. So it's like a KPI, okay? So like in social XR test that has been done in IMG, there was some kind of a measurement that was the performance, okay, to do the task. So here we question if the current metrics are sufficient in our case, and how can we take advantage of behavioral data to go a bit beyond. To make it fast, we had on one side healthy subject, and on the other side visually impaired subject, but with different type of impairment. So the conventional scoring system, the one that is deployed in the physical maze that I was showing before, it's very simple. You see the performance indicator. You have a time score, you have an accuracy score. Time score is basically the duration that it takes for you to do the maze, plus a penalty if you do some kind of mistake and someone has to redirect you. So it's 15 seconds added. I don't know why they put 15 seconds, but that's for each simple error, and 30 seconds for each redirect error, so when you don't go in the right direction. And you have also a kind of accuracy score because you have to show some stuff. So basically, this is conventional scoring system coming from this license maze. Two base metric, very basic, duration and number of errors. If we look at what it does on our data, so we have here this first KPI, the duration to do the task, and is here the number of errors. All the green point corresponds to healthy people, and this color point corresponds to patient. So you see, this type of indicator are discriminant for certain patient. So for these three, you can, but for all the others, especially some here, are a bit, in the crowd. So according to us, the current metric that is in use are superficial and the lack of explanatory power. So that's why we try to expand this KPI, but using the behavioral data. And that's maybe something, some food for thought for the IMG here. So how can we take advantage of rich behavioral data that we have? So we first of all, even healthy people in our maze make mistake. So I should have better described what's going on here. So you have to follow a path, okay? And sometimes you have some object and you have to interact with the object and you have to destroy the object. So if you see the object in the air, you touch it and you destroy it. And we noticed that there were 3 types of error. So error means that there was an object and you did not destroy it and you continue your path. So we notice that sometimes people miss object, but just because it never appears in their field of view. So the way they navigate and as they do their hand movement, they miss object just because the object is not in the field of view. And that's not that difficult to detect because we record all the head motion and we can replicate what they have done and we know if an object has been in the field of view or not. There were other type of error like people missed object while this is in their field of view, but seems that they don't look at it. And this we can notice also because we have also the gaze in, gaze out data on object. So it might be in the field of view, but not looked. And finally, strange case, people see, or they have everything to see it, but they missed something. So maybe it's the interaction that was wrong and so forth. So once we have all these things, we could then analyze the data between healthy, non-healthy, and so on, look at what was going on a little bit more in details. You can check the paper to look to understand that. But basically, the type A error is related to objects which were mostly in high position. So people don't see them because they are located in some place where they don't explore. And even healthy people will miss that because they go too fast. They want to finish the task fairly fast. And type B error was mostly related with objects with low contrast. So they were they gaze in the object, but because of the low contrast, they don't really see that there was an object. And then there was a type C that was difficult to understand. So if we look at the error occurrence between healthy participants and patients, you can see that even healthy people make error. So here you have the distribution of type A, type B, type C error. And similarly, visually impaired participant tends to have, A and B, a little bit more A than in the case of healthy. Okay, so what can we do? How can we take advantage of that? So once we understand that from behavioral data, we look at the error occurrence rate for type A and type B. And this is actually here representing this ratio of type A and type B error for healthy patient. And we could make 4 clusters that somehow describe different behavior of healthy patient. So before we had a kind of with a 2 very naive indicator, big span cluster. Now we can do more subtle measurement. And once we put that with healthy and visually impaired, now we have something more distributed. So what do we do then? From this data, we're going to measure the distance for a given patient, the distance to the different cluster of healthy patient. So we design this measurement, and then we can have 2 refined scores. One which describes the capability of high peripheral exploration, And the other one describes the capacity of contrast related vision. So do you have good contrast vision, or do you have good periphery exploration? And that's what we could get from analyzing this data. So at the end of the day, we have all these, each patient can be characterized from the distance from all the cluster of healthy patients, and you have an overall score, and you have ability in terms of contrast ability and peripheral exploration, and each patient can be better characterized, and it's a bit more subtle than previous measurement. Okay, so that was just once again food for thought how you can combine actually the richness of your behavioral data with performance and start to design new things. Few additional items for analysis of behavioral data. So focusing on head movement, we are actually doing two things. I'm not going into details, but just to give you an idea. So we had some kind of advanced clustering of behavioral data because we have a maze. We can represent this as a graph. What's going on? So this is a graph with a different key moment when you are in the maze. And we look at how you move the signals on the graph. So we are doing graph signal processing. The signal on the graph are the head movement at this different position. And once we do that, we are able to do some kind of clustering. Another thing that we are doing, because in this maze, you can have two types of behavior, you stop or you move. And then we look at your head movement in this different situation. With that movement or moving, we use HMM, combining HMM plus TSNE analysis. If you don't know what TSNE analysis, you should read the paper from YouTube, Yelin, where he's explaining what UVQ is doing, because this is, I think, an excellent way to show the power of TSNE for deep network and understand what's going on. So we are using TSNE for other things to do some kind of clustering and explanation here using HMM, but this is also very useful for understanding what's going on with different type of content, powerful analysis for video quality assessment metrics. Balu, I hope you confirm that this, but if you don't, because it's not, I can't remember in which conference it has been published, this one. Did ICASP or the TSNE analysis of UVQ?
That was last year, I said.
A brilliant paper. Okay. And then I want to finish with something else, which is how we can use this to do, instead of XR for quality of life, it can be also XR, you can speak about augmented reality, but now it's more about diminished reality. And we do that for data augmentation and also to release empathy. So what is the idea is that to put you in situation of visual impairment, like visual field loss in an interactive way, and that help us, for instance, we may miss some patient, but we can use healthy people and put them in the condition of a similar condition of a patient. So just to show you this video, what is the idea? So we developed this interactive system where we're going to simulate the visual loss in VR. And this is fully interactive with, it follows your gaze pattern. So let me show you. So as the guy moving the head, you see what's going on in the viewport, but also this loss of visual field, okay, which corresponds of kind of scotoma, is following also the gaze. So we can simulate many visual loss thanks to that and generate a little bit more of data. One thing I forgot to mention, coming back to how we can share behavioral data, with model like this, we can make some kind of clone, statistical clone. So we can make avatar of data. So these are based on some kind of statistics, probabilistic behavior of regular people. But then from that, it's generative model that can generate traces that are not coming directly from the measurement, but from possible behavior based on observation on other patients. That's a way also to not anonymize. It's better than anonymization, avatarization of data and helps to share behavioral data without disrupting privacy issue. Et voilà. Merci.
Thank you, Patrick. Questions? I have one. In the first part, so the real test is people with visual loss walking, right, in this labyrinth. But in the virtual reality test, they are doing it seated, right? And they move with teleportation with the hand
No.
controller? Okay.
No. Yeah, I did not explain that part very well. So basically, they have a way. There are two speed. Two speed is you can stop, or there is an automatic a constant speed. Okay, and they can stop whenever they want. So it's just it's a on-off behavior. Yeah. So it's not teleportation
It's
at
not
all.
teleportation.
No.
Okay. It's just you
It's,
can.
yeah.
Okay. If
They
you press or
they
whatever.
just they can they steer and they can adjust the
And
by the way we also adjust we make sure that the speed is comfortable.
Okay.
Yeah.
Okay. And they move towards the direction where they are.
Yeah. So basically they follow. They are supposed to follow the darker the brighter
brighter.
gray area and stay inside. And each time they go out, we put them back on the right path.
Okay.
And they have to detect the object. And once they have an object, they destroy it.
Okay. Anyway, do you think that there can be, I mean, it's probably useful to do it like really walking, like not seated?
Yes, but
Yeah.
yeah, it's a bit more complicated because, of course, you can always constrain the space and make sure that your maze makes you but still you need to be next to it. Make
Careful,
sure it's a bit. I would say we wanted a safer condition, and also another thing which is interesting is that it's much easier to deploy. You don't need much space. You can deploy that in any ophthalmologist cabinet. You don't need so it's
Like the
there
whole
is
physical space.
yeah.
Cool. Yeah, thank you.
Yeah.
More questions? Shells.
So you exchange the I mean, let's say the real environment with the virtual environment to do this investigation with visually impaired. So how can you make sure that the virtual environment is recreating the kind of visual environment that the real world is giving, because it's kind of
That's a good question. It's once again, the idea is to test functional vision. Okay, and you can imagine many other tasks. So we did it the easy way because there was this license maze, physical maze deployed, and say, okay, can we do similar things in VR and observe similar pattern and everything? This is just one way to measure your functional vision in an orientation navigation scenario. What offers VR also? In physical navigation orientation maze, you cannot make moving target. You could imagine a complicated mechanical stuff and you have to avoid. Here you can do whatever you want. You can make a moving target, and you have also the possibility to do other things like cooking situation. You can and actually this is I mentioned 2 PhD students working on this project. One of the two is working in co-designing with doctors, but also patient situations that we need to test for the functional vision that corresponds to daily life, but fitted to the type of impairment that they have. So it's yeah.
Yeah, I mean, I don't doubt that there is a lot of possibilities with VR, but maybe a a test where you do the same type of test in VR as in the the other real test environment, see if you get similar result, could be a way to validating that the VR environment is giving the same result. I mean, ultimately, if you are going to have it for validating that medication is working, you need to be.
The thing is that you have to prove that there is an improvement of performance for a specific life task of your daily life. I just want maybe to give you also some figures. This medicine took I think $20 million to be developed, and these $20 million without these things, the maze was about to be thrown away. So someone had to develop a method to show that there was an improvement on the quality of life, and the way to quantify that was not questionnaire. If not done, this $20 million would have been lost, in addition that the people will not receive their treatment while there is an improvement for some of them. So when I heard about this story, and I can tell you there are many others, like also not only for vision impairment, for muscle problems, all these type of things, there are in lack of methods to measure these type of things. And I said, okay, on my side, I spent more than 25 of my life developing quality metrics, subjective methods, and so on for people who see very well, and mostly for the entertainment industry. But I see here there is a huge need to do that. They are in lack of knowledge. So I think that our group, especially, we can really help that. So it's not only about what we said earlier that dates. We can really help in some field where there are also major investment. A lot of money is involved, a lot of, but if you look at the way they evaluate the stuff, they are really at the infant age. So that's, to me, kind of a valid topic to embrace, and where we can also put our expertise at the service of something also important, inclusivity, and better quality of life, healthcare for people. Voilà, c'est pour ça. But at the same time, looking at this data help us to study also the things for entertainment. Huh? There's no question about that.
More questions?
Thanks, Patrick. I'm very much with you on the fact that we need to cater not only to the healthy people, let's say, but also to people who have some kind of disability. I think that's a great opportunity. I'm trying to understand whether the HMD is taking out of the global illumination that, in other words, here they're testing different lighting levels, right? You simulate that by just changing the contrast in the HMD. Is there any way?
No, we change the light and the contrast. Yeah, exactly. Yeah.
Which light? Because there is no light, right? There is only the projection.
But, actually, what we do is we took the real maze, measure with the light under the light condition for each object, and reproduce that in the VR domain. So, and taking care of from gray level, from the bits to luminance in the headset, and so we did the measurement with.
You did the measurement on both sides, okay?
Yeah. So the real, and then end to end in the HMD, measuring with the photometer for.
That was my question, and you answered it.
And similarly for the last thing I presented. This thing, actually, this is not as easy as it seems. Of course, there is all the interactivity challenge, and to have to be able to make a shader that corresponds to a true scotoma. And to validate that, we have the scotoma we measure the scotoma of a
patient.
and then we need to resimulate that in the system, and that means that we have also to make sure that the attenuation of light and everything is the same that what you get for the patient. So that means also we need to characterize the luminance in the system. So basically the shader is you see it's not just a Gaussian or hidden area. It's every pixel has to be computed with the right attenuation measure for a patient using this visual loss equipment that you find in a hospital. Yeah.
Thank you.
More questions? No? Thank you, Patrick.
You're welcome. So, oui. Alors, deux choses. PCS, do not forget to submit your special session to PCS. And if you want to see more about that, the best thing to see is to do is to come to ICME in Nantes from 13th of June to 4th of July. You will learn a lot of things on LMM, but also you will have a chance to have this type of demo, because there is another thing I didn't mention today is how we measure visual loss with HMD.
So I'll take advantage of that. And I will also take a minute to do some publicity. Just in Zoom. Okay, so we just received good news last week, because we are organizing a summer school. We have organized it from 2023. This will be the third edition. It's the International Summer School on Extended Reality, Technology and Experience. We are always depending on receiving some funds, so we didn't know until last week that we are going to do it. We received some support from the European Association on Signal Processing, EURASIP. So we will have this third edition, everything related to XR, not only on quality of experience, but also in capturing, in rendering, in any topic related to XR. In fact, you have there some of the speakers that we had in previous years, like Mar from Google or Mel Slater from Barcelona, also Chisun that has collaborated with Ajit's group in some things. And yeah, we have almost 30 participants each year. So if you want, I mean, we will share this information in the reflectors, but if you know people that can attend, like Norbert, we will wait for you there. And you can share it with your students or your networks. This is a good opportunity to meet there. 7 keynotes, there are also hands-on sessions and some opportunity to present the work from the students. And it's right after ICME, and it will be hosted in Nokia with Pablo and Marta here organizing. Yeah, I'm from San Francisco, from many places, yeah. That's all. IMGs.
Should we cover the IMG topic today, given that we are wrapping up IMG, or should we wait for tomorrow? We have time now. The formality from Pablo. IMG leadership.
Oh, okay, sorry.
Yeah. So as the chair, do you wanna? Yeah, I think Pablo.
So basically, I'm stepping down from IMG co-chairing. I will keep leading, or with help of, I mean, I will keep chairing the 5G KPI activity, but I would like to reduce a bit my activity on IMG, but which is still a key activity for our lab in Nokia. The thing is that the person leading this activity in our lab in Nokia is not me anymore, is Marta. So basically my proposal is also that I stop being a co-chair and I kind of, how to say, nominate or propose that she could like replace me in that role. And, you know, probably, I mean, you know, Marta for sure. I mean, she's been really doing a lot of work you know, in the dark for IMG since the P919 test set, right? So she's been actually heavily involved in IMG since 2018, which means that, of course, she knows everything. And I think it's also a good time for new people coming to chairing teams. So basically, that's the thing. So the thing that I'm leaving is decision. The other thing is a proposal, but something that, of course, I've also talked with Jesus, and we should maybe also take the opportunity for more people to join. I also kind of, since I'm a bit leaving the activity, let's say, it's also maybe there's a know how to handle that. That's also the third co-chair, which is Sensong, hasn't been too much involved in the activities in the last year. So maybe it's time to also find a third co-chair who's more, you know, from the people who's more involved in the activities, if there's anyone else volunteering.
Thank you, Pablo. I think, and thank you for all the hard work you put into IMG. And I also think that it's an excellent suggestion to have Marta being one of the co-chairs for IMG. So that's at least my sense.
Yeah, and I start by thanking you for all the hard work. It's bittersweet, as they say, right? But knowing that you're always there to help the team gives us confidence that, and knowing Marta for all this time, and I think it's a great suggestion, but this is an open group. If anybody would like to, you know, say a few words or would like to raise their hands and maybe joining, but I recommend, I think all of us, that this is accepted and we make it official as of this meeting, the change of leadership.
Maybe we should just ask if someone is opposed to this.
In other groups, we would say, does anybody oppose the recommendation of the existing chair and the general chairs here? Hearing none, it's official. Okay, so welcome to our new co-chair. Okay, that wraps up our IMG, and thank the new and the old chairs for their work, and the continuing chair. We do have roughly half an hour, but the only thing I would like to do, if you don't mind, we can adjourn early today. We have the administration, and the last remaining talk is anyways from Europe, so we cannot really squeeze it now. I'm very happy to hear that a number of groups and individuals expressed interest to host the 2026. It's a good opportunity to at least track who has expressed interest to host the 2026 face-to-face. Do you think that's a good idea to do it now, to just collect so many people? I can say express that I feel very, very happy that we're going to find a good solution. Just want to make sure we track down who would like to host the 2026 face-to-face spring meeting in, again, a time TBD, right, the exact week, ideally outside of the United States or North America, because we like to have a rotation. David?
Yes, we are.
Okay, so let's make a note. Would you like to start tracking down? Okay.
Sure.
Okay, so we have Naim from University of West of Scotland, Glasgow, hosted in the past. Patrick? None? No, I mean, nobody's against anyone. We just take. Okay. Okay, we have the University of Crete in Greece. We have UPM in Madrid. Like, you know, we have a bidding process. Do I hear a better place? These are all excellent places, by the way. Yeah, we are going to eliminate the drunk people. We have Politecnico di Torino. We have. Are we missing anyone? So let's again recap. We have AGH in no particular order. University Politecnico di Torino, Italy. We have University of West of Scotland, Naim. We have University of Crete. Should you put your name as the host? Frosso.
And I also want to mention that the CWI they offered to host already 2023 for so they're standing in line for some time.
Yeah. So the way we should do this, in my opinion, tomorrow. Let's give people time to think about it. There is no real urgency because the next meeting in, say, December will be offline, right? I mean, online, not in person. But I think it's good to create a system where we maybe queue up and some kind of straw poll voting or something that will make it more transparent how we choose. And we just need to have a process, I would say, a well-established process of how do we go about choosing the next. What do you say?
Yeah,
Sal?
I mean, choosing the next has usually been the ones that was available to host, and sometimes for the US it has been kind of chasing around for anyone willing to do it, and in Europe it has all, as you may notice now, it's more or less kind of
The inverse problem.
self-driven.
Yeah, self-driven. No, this is all good news. So again, we have the list now.
So I have AGH, University of Crete, University of West of Scotland, Torino.
And do you have none?
Nantes,
of-
and CWI.
And CWI. Okay, so we have 5 great candidates, and I think tomorrow, part of the administrative meeting, maybe offline, you, me, and Margaret will have a discussion on what would be the process that we will follow tomorrow. Okay, and then tomorrow we're gonna cover and decide. Okay.
It can also depend a little bit, I would say, on when we want to
Yeah.
have it, because every organization has its own
Constraint.
requirement, and if we want to be very specific on when we would like to have the meeting, then it may be just 1 or 2 that could host, or if you just want to have a specific host, then we may
move
be
the-
more flexible with the dates.
Okay, so again, maybe tomorrow we won't reach a decision, but just have a few like ideas and do it through the reflector. Or
It's also not the next meeting. It's the
Yeah.
next meeting.
clearly, it's a meeting after the next.
And we also have to cover a little bit what to do next.
Yeah, so have to pick at least the dates of the next, right?
Yeah, I mean, as I said, we should also, we had it in November, and last time, and before that it was in December, and some expressed it would be better in December, and then we have some suggestions about co-location with other events, and how would that affect the next online meeting, whether we have it or whether we don't have it, so to speak.
Anyways, a lot of things better covered tomorrow, I think. David?
Maybe it's a good idea to, let's say, ask proponents of the
Yeah,
when they are available.
Yeah.
And the dates we decide. For example, some group who wants to meet in March, and there's a location where March is suitable more
Yeah.
more than
so then as a favor, could the people who proposed, let's say, who suggest they can host, give us a range of times that they can host? Kindly send the email to the chairs. So by tomorrow, we're gonna have not only the locations, but also the range of dates that are available. Is that a good idea? To at least have more information in our hands?
Yeah, as far as we can I will send an email to CWI, but we'll see if they will be able to respond until tomorrow.
Yeah, it's possible that they will not because of time zone. Okay, and with that, everybody gets 25 extra minutes to work or go back. Where is Cosmin? No,
Or maybe
we can. Let's stop the recording. Thank you.